We got Adam and his brother making a big pen for their horses, very similar to what we did with the rabbit in class. So the first step is to just fill out the table here, which they've given us this one extra little wrinkle, which is that we have pieces of fence, and each piece is 10 feet, rather than just talking about the length of the fence. So 2 pieces used for length would leave me 6 pieces for width. If I use 3 pieces for length, that would leave me 5, 4, 3, 2, and 1. Okay. So the reason that the length plus the width has to add up to 8 is because we have 16 total pieces of fence. So that means when we break it into a rectangle, we have 2 lengths and 2 widths. So if I looked at just 1 length and 1 width, it would have to be half of that 16. So knowing that every piece is exactly 10 feet, they have the first row filled in there for us, but we just take those 2 pieces of length and say, oh, that's 20 feet. 3 pieces is 30, 40. And finally down here at the bottom, the 7 pieces would be 70 feet. For the width, those reverse, so the 6 pieces would be 60 feet width, 50, 4 pieces is 40, 30, 20, and 10. So the perimeter will always add up to 160. We have 16 10-foot pieces. That is always 160. The area, though, will change based on how we lay these pieces out. So the 700 here is from multiplying the length of 10 times the width of 70. 10 times 70, 700. So I just need to do that for each of my length and width. 20 times 60 is 1,200 square feet. 30 times 50 is 1,500. 40 times 40 is 1,600. 50, 30, 15 again. 60, 20 is 12 again. And 70, 10 is 700 again. So we need to make a graph of that. Now let's make sure we choose our scale wisely. And we need to know to do that the length is independent variable. That does not mean number of pieces, but actual length. So our largest length that we used in the table was 70, right? So it needs to go from 0 to 70 for length. And area is our dependent variable, not width. If area, we need to go from 0 to our largest area we saw was 1,600. Now I have 20 boxes going both sideways and up and down. So my length down here, it would make sense, since they are all multiples of 10, to just number by 10s. Now I can spread that out to make it nice and neat and count by 5s and only number every other one as a 10. Now for the area, I need to get to 1,600. Using 20 boxes, to get exactly there, I could count by 80s, but you probably don't want to count by 80s, and I don't either, so we'll do maybe 100s. Our points were when we had a length of 10, our width was 70, so we had an area of 700. When our length was 20, it was 20 by 60, gave us 1,200. 30, the width was 50, and that gave us 1,500. 40, it was a 40 by 40 square, so 1,600. And then we see the symmetry here, that 50 by 30, 60 by 20, and 70 by 10. Now, should we connect that? Should this be a continuous graph? Well, what that would mean is all the other lengths between 0 and 10, and between 10 and 20 are also possible. Well, they're not, because this fence came in sections, 10-foot sections. So I either had to make the length 10 or 20 or 30, nothing in between those numbers. And that since those were only certain numbers of length and width, I only had these certain values for area too, nothing in between those. What is the shape of your graph? It is a parabola. Now, explain what gives your function this shape. That question's a little bit vague. So one answer could just be that as you increase the length, the area first increases, then decreases. So what you're really explaining is why it goes up and then back down. But I think a better answer would be something like this. Since area is multiplying length times width, we ended up with a linear expression for length times another linear expression for width. And linear times linear is always resulting in a quadratic function. So linear times linear gave us quadratic. That, to me, is the best explanation for why we get a parabola. Okay. Another way you might have read this question, I guess, is why does it have that symmetry? Explain what gives it the symmetry. And that was kind of what I was trying to say up here at this first one, and that was that our length and width start switching places, I guess. Like you could have a length of 10 and a width of 70, or you could call the length 70 and the width 10. So there's two ways to get the exact same rectangle. So each of those possible areas happens twice. So what do we notice? And the big thing there, the big notice, is that the area is maximized at 1,600 square feet. And that happens, this answers the second part, explain how you would rearrange it to get the largest area when the fence is arranged as a square. Okay. When your length and width are equal, or as close to equal as is possible. You know, if maybe we're doing another problem, it might not be possible to get exactly a square, but the closer the length and width get to being the same number, the larger that area gets.